So what we're going to go ahead and do now is we're going to go ahead and see how to set up a basic stream. So what we have is we have an Cisco ASR9K, which we actually are going to refer to as Stan as its host name. And it has a line card in it that is two 100 gig interfaces. 100/5/0/0 and 100/5/0/1. As per the PowerPoint in front of us, 0500 is going to connect to the Spirent Test Center 100 gig interface TC Test Center 1/1, whereas the other one is going to connect to port 1/3. So if we go ahead and move over to the Spirent, what I have already done is I have already opened the CPOC, as you can see in the upper right left-hand corner. I've already opened the CPOC Base .tcc file, which already has a lot of our default settings that some of us like to go ahead and use, as opposed to the Spirent default settings and also views. So we're going to go ahead and do that. The first thing I'm going to go ahead and do is I'm going to actually delete these two offline ports that their only purpose actually in life was to start this file. I'm also going to go ahead and save this off. Instead of overwriting the CPOC base file, I'm going to go ahead and overwrite this and have this be CPOC test, because this is actually going to be used for a CPOC test. So then the next thing we're going to go ahead and do is add a, as we can see from the PowerPoint, we're going to add a subnet. We already have 10.10.1 Test Center 1. And actually, let's go ahead and change this. Let's actually make this 10.1 for Test Center 1 and 10.3 or 10.10.3 for Test Center 3. So if we come over to Stan and do a show IPv4 interface brief, include HUN for 100, we'll see that I had already put IP addresses in there. Of course, now we've changed my mind, and it's going to be 10.10.3. So we're going to do a show run interface 100/0501. So we're going to go ahead and do a config t interface 100/0501 and put IPv4 address 10.10.3.1/24. Now with XR, of course, the other thing we have to do is actually commit these changes. So we'll do a commit and then we'll exit out. We'll up arrow again and actually look at both of them again, and we can see it's 10.10.1.1 for Test Center 1, the one that's going to connect to Test Center 1, and 10.10.3.1. So if we look over here, we're going to go ahead and go over to the Test Center. One thing I do want to point out is it's very odd to actually look at this and see 1 and 3. Well, what happened to 2, port 1/2? The interesting thing is that the line card that I'm using here is a Spirent line card that can either be a 2x100 or it can be a 4x40. So one CFP can actually have, you put the CFP in, it can have a adapter that comes out with two QSFPs on the other side for 40 gig. So we're actually using just 100. That gives us port 11 and port 13. So what we're going to go ahead and do is we're going to add a device. So we're going to go ahead and come in here, click a little bit forward, make sure that we're actually on the port that we wanted. So I'll click back a second. So it is on port 11. Now here's a very interesting thing. If you have a lot of ports here, I don't know about you, but I get confused as to where I was. Am I putting this on the right one? So I might now pause and say to myself, wait a second, did I want 11 or 13? I can't remember. So what I'm going to suggest is before you even do this, is begin with the end in mind. And that is, we'd like to make sure that I cabled correctly. So let's come over here and do a config t and go to 100/0500 and do a shut. Then I'd like you to look over here and see that neither of the ports went red. Both of them are still green. Now, of course, if you're not familiar with XR, you won't realize that I actually have to do a commit. When I commit, I've committed the config changes. Now that port is down. So we can actually do a description to Spirent, or just to Test Center 1/1. And no shut. Now, why am I not doing a commit again? Just because of the fact that I'm going to do the exact same thing to the other one. I'm going to do a shut. And now when I do the commit, I am committing the no shut on 100.05.00, and I'm also committing the shut for the second one. So the red and the green over here should flip. And it has. So this one has gone up, that one has gone down. So we have determined that we're correct on this. So what we're going to do is, so that we can better understand what's going on, we're going to go to port 11. We're going to go to location. This is even more so important when you have multiple devices in your network. We happen to know that this is stan 100.05.00. Now, right here, it says append location to name. Now, what it means by location is it actually means that it'll say stan 100.05.00, which is just our definition on the stan on the ASR9K side, but 1/1 is still the Spirent Test Center port. So I typically always leave that there. Why do I leave that there? Because obviously, as you can see, 11 is before 13, because you can reorder these, of course. So let's go ahead and fix this over here. So stan 100.05.01. And let's go back over here and no shut that poor guy and commit the change. And now they're both green. So let's go ahead and start configuring. So if we actually go ahead and add a device, we're now on stan 100.05.00 and we're on 1/1. Now I happen to know, because I'm coming up with this, what IP address that's going to be. We want IPv4. We want this to be Ethernet, which it's an Ethernet card, so not much of a choice there. Number of VLANs. We're not actually going to do VLANs, so we're going to leave that blank, which will make the number of VLANs as 0. Then we'll go ahead and come over here. These were the default IP addresses that we had in the user default manager system defaults. So we're going to go to 10.10.1. Now here's an interesting thing. What should we use for the 4th octet? I am not a fan of using 2 or 3, even in a simple environment like this. The reason is because we could still actually have change. We could start with one thing, I make myself 2, later on the customer might ask, well, what happens if we put another router in there and we do HSRP? So I stay away from 4th octet 1, 2, and 3. Typically, actually, in a real-world environment, when I'm using /24s at the end, I actually use a 101. The reason why I'll use a 101 is so that it is a distinguisher to me that the Spirent Test Center is always 101 or above. And then I'll use between 100 and below as other devices on the network, PCs, firewalls, servers, whatever, or other traffic generation tool that's not Spirent. So sometimes I'll go ahead and do a 101, but for something this simple, I would probably use a 10. So we'll just go ahead and go with a 10. So I'll go ahead and go with next, 10.10.1.10. I'm perfectly fine with the MAC address that we're using. We're going to be doing Test Center 1 and Test Center 2 are going to be in 2 different VLANs, so we don't really have to care, 2 different subnets, so we don't have to care whether or not their MAC addresses are the same or not, since they will still be unique to their subnet, which is all that we care about. So we're going to go ahead and click Next, and we will call this, we can actually, we can't change the name of the device right now, I forgot. And so now we actually have one device. Now, there's a few things that we can do here. One of the things that we can do here is we can name the device. So we can actually say that this is going to be subnet 1. I don't know. Subnet 1, or we'll just call this host 1. This is just a name. Now the tags are just a way of organizing. So we could just say host, but let's say we don't like that. Let's actually say that we want to call it 100. So we want to know about all of our hosts that are connected via 100. So we can say add. And I'll explain why later. Device count, we only have one. IP address 10.10.1.10, 24, 10.10.1.1. And so this is my source MAC address. This is who my default gateway is. Now, what we also can do is we can also capture an interface and figure out what's actually happening. Now, one of the things is if you capture an interface, you actually have to have the capture option selected as to what is your traffic generator, your analyzer that you want to use. So we're going to go ahead and go in here. You can still capture without it, but you just can't do a capture and view. You have to do a capture and save. So one of the things I really like about the traffic generation tool, the Spirent, actually is, for example, let's say I went ahead and I captured this and I said start the capture. And then I came to this device and I highlighted it and I right-clicked it and I actually say ARP. So start an ARP. So it's going to go ahead and ARP, and then right down here you'll see all attempted ARPs resolved successfully, so you know you're good. You can, even if you want to, scroll over and find out what the MAC address, so the IPv4 gateway MAC address state is resolved, and the MAC address of the IPv4 gateway is this MAC address. By the way, respond to pings, you can see right now that the devices are not set up to respond to pings. So if I actually did a ping 10.10.1.10, I will not be able to actually ping that device. And if we actually stop the capture now, we'll be able to see two things. One, we'll be able to see the ARP that just happened, and two, we'll be able to see Stan trying to ping our end device. So now we'll go ahead and go to view. It'll open Wireshark, and so we'll see the ping request coming in, and we don't see the other, and I think that's because of the fact that I missed it. So I think I did that incorrectly. So let's try that again. Oh, because it was an ARP, right. It wasn't a ping that I did. So let's take that back. I did an ARP and I did a ping. So here is actually my ARP. Got myself confused there thinking I had done two pings. So here's my ARP. So this is from the Spirent. I don't mind leaving the Spirents as their default with a 94 right here. Very much quickly lets me see that that's a Spirent. So this first right here is the capture of the ARP. So address resolution, the source is the Spirent, the destination is the broadcast asking who has 10.10.1.1. Please tell the Spirent traffic generator port. And this is Stan, the ASR9K, responding with an ARP reply. These are the ping, the echo requests that came in from Stan that are not getting responded to. Now, if we actually go ahead and we close that, and we go back over to here, and we actually go back to the device and we click respond to ping, and then we do the capture, we will actually get a response to it. We can then stop the capture and view the capture, and we'll actually see the Stan, the ASR9K 10.10.1.1 pinging us and us doing an echo reply. One of the other things, though, you will notice is that you might actually get an error message letting you know that if you have pings enabled, that can be intensive. So I only put respond to ping on when I'm trying to troubleshoot. You can still ping in the other direction. So just because I'm not responding to pings doesn't mean that I can't go right-click on that device and ping and get a ping back. It's just that I'm not going to be processor intensive and actually respond to people doing pings on the traffic generator. So I've created a host. Now I have a couple different choices. I can either go over here and do an add and create another host, or another thing I can do is I can come here and I can actually right-click, copy this device, go over to the other port, and I can paste the emulated device. Now, when I'm actually creating devices, I'll actually be in the physical interface, so I know I'm in the right place. When I want to look at multiple devices, I usually go up here where it says all devices. Now, what you will notice is that the name that was over on the other side did not come over. So that's host 2. Another thing we could have done, by the way, is if I made this junk, we could have gone ahead and come up here and then right-clicked right here, right on where host 1 is, and we could say copy down, which would make junk host 1, or we could copy down and fill increment. So it becomes host 2. Now, this isn't the address we want either. So again, as long as we're highlighted, we can go ahead and we can say fill increment. Now, what we want to do is we want to have, oops, it's not here, right? Because it's the next one, we didn't make it 10.10.2.10. So if I had actually clicked fill increment, then the second line 10.10.1.10 would become 10.10.2.10. We don't want to do that. So I'm going to go to fill custom, and I'm going to go ahead and say that what I really want to do is I want to step the third octet by 2. Now, as you can see, clearly with only 2 devices here, I really could have just done this manually as well. So now this becomes 10.10.3.10. Now, it doesn't automatically assume that the default gateway should be changed as well. So we're going to do that the old-fashioned way, since there's only one stream here. We're just going to come over here, get into it, and just change that to be a 3. You'll also notice that their MAC addresses are the same. Sometimes what I'll do is I will do something that everything from one port will get a 1 here, and then everything else will get a 2 here, or something along those lines. Again, since this is layer 3 and they are in different subnets, the fact that they are the same MAC address is not important. However, if you're doing any kind of fabric path, OTV, layer 2 extension, or just layer 2 testing, the MAC addresses are going to be critical and you're going to want to have them be unique. Let's talk about the apply button. So the apply button basically means this is everything that I've done here is locally on this graphical user interface on this Windows box. It has not been pushed out. These instructions have not been pushed out to the Spirent Test Center appliance and to the ASICs on these line cards. So now we're going to go ahead and push them out. That's the apply button. Good practice is whenever you see that it's green up there, go ahead and click apply. So we have 2 different hosts, no big deal. And I can either come here, and if we look, the second one, which we just created, if we move all the way over, oh, look, this one's unresolved now too, because we made a change to it. So let's go ahead, since we're new to this, and let's go ahead and move the gateway address over. So we can actually come down here, we can right-click and say Custom View, and we can move these up. So we can actually move these up higher, especially since, again, we're new to the Spirent Test Center. And so you can go ahead and move these up. And then go back over to your main view. And then typically what I do is I tend to make these a little bit smaller. I don't really need to have this device count so big. So I tend to go ahead and move the column so I can actually get a better view of everything. So if we look here, the devices are perfectly fine, but their ARPs are not resolved. Now, one thing we could do is we could come here and then we could right-click and click ARP, or we can also click what we refer to as the big ARP button in the sky right up here. So I can click ARP. We can see that they went from resolving to resolved. So we now have devices that are sitting there waiting to talk to each other. So now we're going to create a stream. So we're going to go to Streamblocks over here, and we're going to add. Now what's going to happen is if you have lots and lots of Spirent Test Center ports checked out, they're all going to show up here. And if you have tons of devices, they're all going to show up here. So let's say I had line cards all the way down to down here. So what I might do is I might check this, which will uncheck all of the imaginary ports down here, and then I will just check the two that I want. So I'm going to check the two that I want. I'm going to go to next, so I will only see the devices associated with the two ports that I checked. So as you can see, it says source here, destination here. Well, what I really want is I want this source on 1.1 to talk to this guy over here on 1.3, but I really want the arrow in both directions. So I really want the arrow in both directions. So what I'm going to go ahead and do is I'm going to go ahead and click over here for the source, over here for the destination, and I'm going to say bidirectional. I also like doing show all the headers because I like all of that. It's going to be 1-to-1. This is my preferred controlled environment, 1-to-1 paired, so I can see what exactly is being lost. I'm going to add it, and when I add it, you'll see that there's an arrow in both directions. If you don't see that arrow in both directions, you have done unidirectional and forgot to click the bidirectional button. When we go to next, it's going to default with 128. The default with 128, I don't necessarily like 128, nor do I like 1500. The reason why I don't like 1500 is you can imagine something coming in with 1500 bytes, and then it has to go into an L2 VPN or L3 VPN tunnel, and it gets multiple MPLS labels. Or it goes into OTV or some kind of GRE or whatever, and again, it gets transported within a tunnel. So I don't like getting close to 1500, 1400, don't know how many tunnels I'm going to get into. And I also don't necessarily like 128. I might be going through a very small end device, and I might have some kind of inspection on. So I'm going to go ahead and go on 1024. 1024 for me is a nice, simple, safe environment to start, just to make sure my traffic is working before I actually start going into the testing that I want. The next thing that I'm going to go ahead and do is I'm going to add a header. I'll explain to you why I add the header in just a second. So I'm going to add a UDP header, and I'm going to say basically that I don't care about what the port is. So we're going to go next. Now you can go port-based or you can go rate-based. I would say, honestly, for the majority of my testing, I do rate-based. And then I will actually go frames per second. There is a reason. And I will typically go 1,000 frames. So rate-based, frames per second, 1,000 frames. And so I'm going to go ahead and say finish. And then once I finish, you can see that I have information that's on my graphical user interface that has not been pushed out to the Spirent Test Center. So the first thing I'm going to do, because I've made a lot of changes, is I'm going to do a save. The next thing I'm going to do, because not all of my customers are familiar with the Spirent traffic generator or any kind of traffic generator, is I'm going to come over here and I'm going to give this a name. So I have host 2 talking with host, host 1 talking with host 2. So you can see host 1 is the source. On this one, destination is host 2. And so this one is going to be host 2 talking with host 1. Now typically I'm going to have a lot more information there. Another tag that I'll probably give this is I'll probably give this 100 testing. Well, I'll just call this 100. And the reason is, again, is because of the fact that I want to be able to quickly see with my tags that what kind of testing this is. Assume that I have hundreds of, well, that was, assume I have lots of streams here, and I want to differentiate the ones that I'm using for unicast or 100 gig versus multicast or whatever. So I'm going to go ahead and click apply. We can see that our little button in the sky is there. So my streams are there. So we're going to go ahead and click the big ARP button in the sky. All attempted ARPs resolved successfully, and now I have two choices. I can either start the traffic by this button up here with the little traffic light, start traffic on all ports, or I can also come here and just select which ones I want. For example, I could just come to this one and just only have one direction go. Now you'll notice that this traffic is actually going because of the little arrow right there. The little arrow right there says this traffic is going from host 1 to host 2. We can also see that right here. We know that host 1 is on Spirent Test Center 1.1. There is 1,000 signature frames per second, or 1,000 Spirent created packets that are going out frames per second, 1,000, and our other one, host 2, which is on Spirent Test Center 1/3, is receiving 1,000 frames per second. So we can then go ahead and start the next one. Or again, we could have hit the big the big test streams button in the sky. And now you see that we're working perfectly fine. You can actually come over to this other view right here. So typically for this view, that's all I care about, is I'm sending and receiving everything that I expect to be sending and receiving. Over here, I'll go to advanced sequence, and I will typically look here at how many drops I've had. I've had no drops, so everything is good. And the other thing that I will typically do is I will also typically have, these are DRVs, or dynamic route views, and if I am expecting drops, like I'm going to pull a cable or something like that, I will actually start the dynamic route view by clicking this play button. And more on dynamic route views later. But that's it, and if you want to stop the traffic, you can either stop one at a time, or you can just hit this stop button. So that's it. Have fun with your Spirent testing.